Hello, good day. I'm sure you enjoyed that short break. You went and grabbed yourself a drink or something, a nibble to have a bite, and you got the energy back flowing into you. So now let's get in and learn today about generating those interrupts for the GPIO and the USART, and you will see for yourself how when an interrupt or when an event occurs and how the main program halts and goes and executes the interrupt. It's all very exciting, and I'm sure you will find it exciting as well. So let's go in, and I'm going to open the STM32 cube ID and we'll start from there. So you got to double click the STM32 cube IDE, and that will open in the background. It's opening. Once it's open, I'll let you know. But also make sure you connect the hardware as well. Otherwise, you will get error messages if you don't connect the hardware. Um, yeah. So it's downloading on the background. Um, just a minute. Once it's ready, I will show you the IDE. I don't know, it's showing the loading symbol, but it's taking a long time to open. Won't be long. I hope in the meantime you are able to collect through in your mind about what we learned with the interrupts and how you can connect that link to the programming concepts. It is very easy and nothing is hard, so please stay with me and I'll show you everything from line 1. Okay, I think it's opened. Yeah, um, I'll just maximize this. Okay. Okay, let's go to file, new, STM32 project. STM32 project. And this will allow you to set your target selection. So you got to set your board so that you can check using the output here and see in the SFRs the output. This is the SFRs, and also you can check in the console as well the output. So it's loading on the background. As you can see, the blue circle is going round and round and round. Once it's ready, it will let us to choose the target selector, but just at the moment it says not responding. So oh yeah, there it is, it started. Sometimes because it has got a lot of projects opened up that we connected to the project tree, so it has to check a lot of background view file checks and the memory locations and all of that. So that's why initially when you open the IDE from scratch, that means you shut down your computer and the next day you logged in, and the very first time when you open the IDE you will face this problem. So don't panic, it's just doing its behind the scenes check just to make sure everything's okay. Okay, now we are in target selection. Go to board selector, and then it is a Nucleo F411 RE. So this is the board, as you can see, Nucleo F411 RE board I have connected. So I'll take this view off. So type that here in Nucleo dash F411RE, F411RE. Okay, and you got that. You click here and this will ask you to click next. Now you can give some relevant name to the day. So today we are on day 16, and it is about in interrupt, and we're going to use the push button, so I'll leave it as GPIO, and also we're going to learn interrupt with using USART2. So that's a name, and then set the targeted project type as empty, and then click finish. This will take some time to create all the necessary files, and then it will set you up with the project tree. So in the meantime, I will show you the in the data sheet. If you go to the functional block diagram, as see now, so this is the functional block diagram. So today we're going to use a push button, and that's connected to PC13. If you go to nuclear schematics, and the push button here is connected to PC13. So I'll show you where the push button is. It's a active low push button. There it is. No, that's a reset, sorry. Yeah, B1 user blue button. So if you see in the board, I'll show you the board view as well. If you see in the board, so we're going to press this button and create the interrupt. So that button is nothing but this one, B1, and that is connected to PC13, and this is the microcontroller, and we need to connect port C. So to do that, you need to enable the clock for GPIO port C, and also enable the clock for, because ports are connected to the advanced high performance bus. So you need to enable the clock here, and also which peripheral that's connected to, because the interrupts are connected from the peripherals. So we got to enable that as well. The external interrupt EXTI, because we are learning about the interrupt, so you got to use this EXTI, this one. So, and that is connected to APB2, so you need to enable that as well. So these are the two clock enables, and then you need to copy all the EXTI mask registers, all those falling edge, the pending registers, etc. I will show you. Okay, so the project is created. Go to SRC. SRC stands for source. I'll close all the other open files so you won't get confused. So I'm closing down all the other files. So we are on Day16 under source. Double click main C. As you know, anything between these all for reference, just to say what file it is, what who wrote that program, and where your program sits. Is it in the main of the whole program, or is it the header or the footer? Likewise, you need to give some information. So anyone in the team, if they want to use it, they will read the reference file and they know exactly where to use. So that's how in the industry, this is how they do it. So this is the main program, has include stan I and int.h. I'll remove all the pre-written programs, and we'll start from here. So the first step, you got to enable the advanced high performance bus, and then enable the clock on the advanced peripheral 2, APB2. So to do that, first I'll go right click, compile the project, just to start with the .elf project, and then you need to set up the debug configurations. And then you can go to the SFR registers, and you have to pick all the necessary registers from there and use it in the program. So that's what you're going to learn now. That's loading. building project, it's on 19% now, as you can see. 0 errors, which is always good. Now go back, right click, debug as STM32 application. That will directly take you to the edit configuration. So you can click like that and it will automatically link. If not, you can click as debug configuration and then choose the file. So it's all linked.elf. Go to debugger, make sure in the interface you set the board, the programmer, because the nuclear board comes with the built-in programmer for debug options. So you need to click on that, enable this, and then the serial wire viewer enable as well. Then go apply and then OK. So this will set and download the program, and it will be ready for the board, and you can start to do your debug troubleshooting. So I'll take this view away from you so you know the program what I'm writing. Okay. So 0 errors, 0 warnings, which is a lovely thing to see as a programmer when you see that. But also when you get errors, that also gives you a really good time, because you seeing some error and that makes you to learn, because through errors only you can learn. If you don't get any error, then yeah, you do learn, but not new things. When something pops up as an error, then you know next time. So which is always all good. Okay, so now we are in debug mode. So I'm going to go to window, show view SFRs. Show view SFRs. So today we are using the interrupt, and we are using STM32F411, the nuclear board. The first step is you need to enable the GPIO. The GPIO will be, first you need to enable the high performance bus. That will be in the reset counter clock. You have to enable the AHB1ENR. AHB1ENR, so click on that. You need this register name and also the address. So first let's declare all the pointer variables here, and then we'll go one by one. So I'll start first one, caps, uint 32 underscore t asterisk, and then you need to declare pointers with a small p. So copy this register name, paste it here. You got to enable the clock, so typecast again, uint 32 underscore t star, and copy the address 3830. Copy that, come here and paste it. So this is to enable the AHB1ENR, your GPIO ports ENR. The next step is you need to enable the external interrupt EXTI, and that's connected via the APB2 ENR. So the next is you got to copy this, because we need this. Copy, and then APB2 ENR, the second register. You are enabling the peripheral bus now, APB2 ENR, and then typecast, and its address is, you have to copy this, come here and paste it. So we got two addresses. So this is to enable the clock for GPIO-C, and this is to enable the clock for APB, or you can say EXTI, external interrupt. Clock EXTI. Okay, so the next register we need the GPIOC, because that's where the port is connected, the push button. So you need the GPIOC. So again, copy this line, and if you want you can give a space, so this will give something. So you can create a new label, GPIO. Then you can copy that address 0800 4002 0800 422 It's better to copy and paste, because by typing you sometimes make a error. So yeah, this is to for enable the port GPIOC. Oops, sorry, my bad. GPIOC, done on this. Okay, so copy this, and now we need all the registers for the EXTI register, the falling edge, pending registers, and all of that. So I will go here and paste it 3. So the next one is you need the EXTI PR, the pending register. So you need to look for the EXTI, which will be here, EXTI. In this EXTI you need you will be using all these registers. So this is the falling edge, falling time, falling trigger selection register. This is the rising triggers selection register, and this is the pending register, and this is software interrupt event register. So in our program we only need the pending register and the IMR register, the interrupt mask register, and we are going to do the falling edge. So we need this FTSR. So first I will copy the PR register. So it will be EXTI PR, EXTI PR register, and the address is 0 AC 14, Control C 14. This is the EXTI pending register. Okay, the next one is interrupt mask register. So EXTI IMR. So this one, IMR, interrupt mask register. So click on that IMR register and copy this, Control C, come here and paste it. So this is the EXTI interrupt mask register. Then the next one is EXTI falling trigger, sorry, EXTI FTSR register. This one, falling trigger selection register, falling trigger selection register. Copy the address, come here, this is falling trigger selection register. So if you're not sure about what name it is, you just go and put your mouse in there and it will tell you all the hover the mouse there and it will tell you what it is, selection register and all the names. Okay. EXTI, and this is port GPIO. Okay, so now we got all the registers. Now we need to go to the control registers. For this selection you need to because we are using the falling trigger selection register, so now we need to go to the control register, which is this in the EXTI. So we need to go to EXTI FTSR. Yeah, in this FTSR you need to go for system config registers. The next one, system config registers. Yeah, system config. And as you can see, there are 4 different registers. So that's the external interrupt configuration register 1, configuration register 2, configuration register 3, 4, 5 likewise. So as you know by now, there is 15 exceptions in STM32F411, the one that we are learning, and our push button is connected to PC13, so that is on 13th external interrupt. So it will be on the first one will be 0 to 4, that's 4, 8. So anything after 8, that will be on this is from 12, so from 13 onwards it will be on CR4. So this is a system config. I'll show you where exactly in your data sheet. System config. Sorry, go to the reference manual and go to the contents and go to system configuration controller, sysconfig. If we come down, we are trying to enable the bit control register 1, so that is your first one, second one, third one, fourth one. So if you use for instance the LED, so that could be in this one of these 2 interrupts. So we are using PC13, control register 3, so 12, 13. So you need to use this 4 registers. On control register 4, external interrupt 13, you need to set all these pins 7, 6, 5, 4. So that's what we're going to use that. So copy this system config. I need to copy this again, Control C, Control V. Now it is system config, sys config, and you got to say which it is. It is EXTI CR4, and then copy this address as well, Control C, come here, Control V. So EXTI 13 is where PC 13, the push button from nuclear schematics. If you check on the schematics, this is what you will see. Okay, so that's done, nuclear schematics. And the next one, we need to set this as the priority. So we need to understand which address register this priority is set to. As you know, PC13, it is the 13th external interrupt, so therefore go back to the manual, the data sheet, and I think it is on page 47, the vector table. Oh no, that's alternate function. Vector table, nested vector table, boot modes, regulator off, RTC. Okay, I'll check in the reference manual. We need ISER. Vector table. Okay, so this is the vector table we need for the EXTI, external interrupt or event controller, EXTI. So in this we know that we're going to use the external 13 EXTI, so that this is the external 0, external 1, external 2, 3, 4. Likewise it will come down. What we need is we need to look for the position number, which position it is. EXTI 17, there it is. This is the EXTI 15 to 10 and its position is 40 and its priority is 47, so this one. So we need to use this. Okay, EXTI 15 underscore 0, so that is external interrupt and that's connected to the NVIC. If you see the block diagram, you will see that that's connected to the NVIC. So go back to the code. You need to go to ARM Cortex because the NVIC is connected in here, the register, NVIC register. So we need to use the interrupt service E1 as you know, interrupt set enable register. As you know, every register in NVIC is 32-bit, so we got to use this register. So being why we are using ISER1, because we just checked the position is 40, so we need to go to the 40th bit. So every register is 32 bits, so ISER0 will have 0 to 32, ISER1 will have 33, 34, 35, 36, so 40th position, 40th bit will be in ISER1, so that's why we're going to go for this ISER1. So copy that again, line, and we need this register, copy. So this is the for interface controller with the microcontroller. You need the interrupt set enable register 1, ISER1. If you don't know, just go here and hover the mouse, it will say interrupt set enable register. If you open this, so this will be the bit that starts from 33, 34, 35, 36, 37, 38, 39, 40. So the 8th bit we are after. So 32 NVIC underscore ISER1 and copy this address. Copy EXTI 13 and NVIC. If we put this and position 40, priority 47. So if you write it here, then you would know why you have chosen that. Okay, so that's done. Oh, STI priority. Trying to delete only that. Okay, delete only the nuclear schematics. Okay, so this is done. Now what is the next register? So we chose which register we're going to connect the button to. So now let's write the function. We need to initialize and write the function for the void button, for the push button. So I'll create a function here, void button initialization, init of void, and I'm going to write the function. So first you need to enable this bit first, and we're using GPIOC, so therefore it is the third bit, meaning 0, 1, 2, the second bit. From 0 it is the second third bit, but if you say 1, 2, 3, then that's a third bit, so it's the second bit you have to enable. So copy here, paste it, and you just do to enable you need to just R that R enable unsigned, use for unsigned, so you're enabling the second bit. So if you go to why am I doing this, if you come here to the reference manual, if you go to GPIO registers, if you come here the first register, GPIO registers. So if you come here, we are enabling the GPIOC. This is port model, the AH1BENR RCC. Sorry, you have to go to RCC register, reset and clock control. If you come here, registers, RCC registers. So enabling AHB1ENR, that's a pull register, so keep scrolling. That's a configuration register. AHB1ENR, it's a reset. APB2. So AHB1ENR, so 0th bit is port A, first bit is for port B, the second bit is for port C. So we are enabling this, so that's why I put the 2 in there, enabling this bit, GPIOC. Yeah. Enable GPIOC. Okay. And the next one, you need to enable the peripheral where it's connected to. So copy this, paste it here, and then simple R, R1U 14, shift it 14 times. I'll show you why. So again, go back to APB2ENR, go to APB RCC registers, click that, and then go to APB2, RCC, APB, AHB, APB2. So APB2, you need to enable this bit, system config bit 14. So that's why you have to left shift come to this bit. So bit 14, system config, you need to enable that for the system configuration controller. So this is the one will connect with the external interrupt, so you need to enable that. Okay, and then you need to enable the control register for the external. So copy this, and you're going to R this with one U, unsigned U, then the fifth bit on this one. So this is for enabling sysconfig, and this is for enabling sysconfig control register 4. So if you go back here to the contents again, go to sysconfig register, go to, I'll minimize this so I can go faster. So go to sysconfig registers, and you need to enable the control register 4. So if you come here, we need EXTI13. So to do that, because we're going to set this as an input, to make this as an input, EXTI13 bits 5. So if you come down, if you make this as an input, you got to write EXTI13, this bit as 0, 0, 0, 1, 0, which is external interrupt. So for port C, it is connected PC13. So X represents which pin, so 13th pin. So you need to set that as 0, 0, 1, 0. So you need to enable the bit 5 as 1. So that's what I said here, 5. So enable that 5. So we are enabling the register. Okay. So now you need to tell the falling edge. You need to enable the falling edge, control C, falling trigger, sorry, not to confuse you. Then I'll copy this and I will modify it. Control V. We are connecting PC13 on the falling edge, so this is enabling push button on the EXTI FTSR. So again, go back to the register, go to EXTI register, sysconfig, that's a map, EXTI, what is it, system config CR, EXTI FTSR, EXTI, look for FTSR, EXTI external interrupt, it will be in here, system config EXTI 13, so this one you're doing it. Okay, EXTI FSR, EXTI FTSR. So come to the STM32F11 FTSR. So we are enabling the 13th pin, this one, TR13. So this is where the button is connected, so we need to enable that. And then you need to do the mask, the XTI IMR. So copy this register as well, you got to enable this. Control V, and then you need to copy this Control V. So you're going to IMR again. IMR, you linking that to the 13 M13 MR13. So the 13th bit will be enabled. Okay, and now you need to set the position now. So to do the position enable, you need to go to the register where it lies, the 32-bit register. Copy this, paste, and you got to enable eighth bit. So 32 plus 8, 40th position. So you're enabling the EXTI 15 EXTI 15 to 10. You are using EXTI 13, which is position 40. So that's what you're doing it here in this line. So you just enabled. Very good. So now I'll just go into the main program and I'll just call the initialization, the button initialization. So what did we say? But small case button init off. So I call the function, and now you got to write the interrupt handler for this. So to do that, you need to go to startup file. This is the startup file. So copy the exception 15. Oh, sorry. I'm in the linker description. Oh, somebody was yelling. Okay, this is the startup file. You have to copy EXTI 15 handler name, EXTI 15, EXT 1, 2, 3, 4. This one. Copy this name, because we are generating the interrupt by an input. So you need to copy this and call the function. So go here, go to the main program and write a program for that. So void interrupt handler, you're creating the interrupt, void of, write a function. So we are just using the printf statement. So printf button is pressed \n, and then you need to say that you need to have a value, return value. So for that you need to say which one you are returning to. So you need a pending register, returning the value to the pending register, and the pending register is connected to this switch push button 1U13. Okay, so now we did all the program and everything finished. Yeah, now just save and compile the program for start. So build the project, right click, build project. So what will happen now is once it starts to build, when you press the blue button, so now I'll enable this view, enable the view. So when I press this button, this blue button, this I'll take the view off. The program, the main program has to stop and it has to come and execute in this line, the printf section. It will move on here. So that's what the interrupt means. This is running the main program, and whenever I press that button, it should halt this main program, the button initialization, and come to here. And that's what we are we need. Button is press studio hash include. Okay. Because we are using printf statements, it's giving the warning that I'm not including that library. So I'll just copy this library and paste it here. stdio save that and run again, build the project. Okay, so we included that file. So now right click, debug. So debug is to download the program to the microcontroller. So it's ready now, downloaded, and now we need to run to see whether the interrupt goes to that location. So let's check that. Okay, the program downloaded, verified successfully, that is good. So now we'll go, wait, okay. So I'm going to run the program. So after you press run, it comes to the button in it. So now when I press the blue button, it has to halt this program and has to come to this function, and it will stay in here in line 55. So I am pushing this button now. Push. I pushed, so I need to terminate and relaunch again, and then push the button. Terminate and relaunch. It's loading still. Yeah, switch. Now run the program. Run. Now press the button. Okay, press the button. It's not moving yet. Okay. Let me try something. Change this to, I'll take this view off, so I'll do some minor changes and see. Volatile. Create this as volatile. Yeah. Now terminate and relaunch. So it should work now with the volatile function. Just checking my notes. You are okay. Good. Zero warning. So it's going to go in, and once it switches, then I can hit the run button and show you how, when an event occurs, how it stops. Okay, switch the main function and moves to the handler that we generated, the exta. Okay, so by default the program will halt here. It shows that it's in initialization mode. So I hit the run button, program is running. So I'm coming here and pressing the button, blue button. terminate and relaunch. Terminate and relaunch. Okay. Come on, relaunch. I'll call this function. Create the function. Save. Build the project again, just to make sure there is no errors, and then we can debug and try again to run, and let's see if we generated the option now. Okay, that's good sign. So debug. Switch. Okay, so pressing the blue button now, and running. So if you go and see the Windows show view SFRs, if you go to EXTI, the error reading value. Okay, error reading value. Why there is an error? 8th bit. ISER1. Let me check ISER1. If we relaunch, switch 13th bit, 5th bit, 14 to, and then int minus void. Okay, sorry, I didn't include a function to make sure it runs. So I will just create a while loop to say to run something. Okay, to run something. You don't need the for loops. This is some function. Then go to the handler and copy. So now if I go save, terminate and relaunch, this should work. So now it should has some while loop function. Debug as STM32 application. Yes, it's connecting. We have to wait. It's loading. It will change to debug now. Debug mode 51%, 70%, 79, 89. Yeah, switch. Checking on the reset handler. Yeah, okay, You go now and click run, and then press the interrupt. (32-bit) NVIC ISCR1, yeah. If we go to EXTI 13th bit, EXTI 13th bit, which is that one, should change. Just one second, I'm just troubleshooting myself to get to that issue. One CR4, I enable that, and then FTSR and IMR 13, yeah. Then NVIC is 8th bit. Yes, so only you don't have to separately call this, so let's see. EXTI PR is 13, EXTI PR is 13. Returning EXTI PR 13, yeah, okay. Let's see. Interrupt handler, everything is there, void, yeah. Then switch. Once we are in the mode, and run, and then come and push the button, yeah, see, I clicked and I set a breakpoint now, so it's halted the main program. Now as soon as I press the button, it's going to the interrupt. So I'll do a relaunch again. So you just watch. That's the interrupt we are introducing. So I just created a breakpoint there just to show you where the program stops. So switch. By default, it started to download and it starts to execute and it runs. It is in the main program, so it is running. So suddenly when someone is pressing the interrupt, you watch, as soon as I hit the push button, the cursor from button in it on the main program will jump to printf statement, meaning the button is pressed. You got to go and run the program again, so it will start to run and then hit. See, as soon as you press, it jumped to printf. So so that's how it is. Let me see if I can show in the output as well. Okay, if I click start trace, okay, I will run again. And then start trace. Okay, it's working. So please go and enjoy that break. When you come back, I'll show you how to generate the interrupt using user2. So I'll catch you shortly in about a couple of minutes. So see you then.